This is Steven from LegitTechTutorials, and welcome to Advanced Java tutorial number 25. And I don't know what exactly I'm going to call this tutorial, whether it's going to be intro to algorithms or sorting. So this is probably if you're an independent, teaching yourself type thing, and not really going for a computer science degree or whatever. I would suggest this might be where you stop, and then just look for other videos of things that you want to continue on. But this is, kind of the where I let you go type thing. And you could continue staying and learn more things, but then it's kind of, you go to what you want to learn. And if I have videos on what you want to learn, then that's cool too. So because I'm gonna go over mainly the idea of these sorting, and then I'll probably have another video showing you just exactly what sorting is. So this will probably be introducing algorithms, and the next one would be talking about sorting again in Photoshop. Here I have it up in Photoshop so I could draw stuff, and then we'll go into the code. So why are we looking at algorithms, and why are they important? So computer science is all problem solving. So for example of those problem solving, I could give you these 3 different examples of sorting, and don't worry about if they're a little abstract to you, because if you really want to learn about them, then you stay for the next 2 tutorials or whatever. But this particular setup will show you how the more you think about things and the better you are at solving the problems, the faster your program will be, the better your program will be, the cleaner your program will be. Not necessarily easier to understand, because some of these algorithms really get dirty quick. So, for example, let's say we have this array. We have 1, 2, 3, 4, 5, 6. So 6 indexes. So 6 is the index, and this is 0, 1, 2, 3, 4, 5. I don't know why. I guess there you go. Now it's 2. So sorry about my drawing. It kind of sucks. I could have a tablet, but my handwriting is probably not much better. So let's say we want to sort this particular array from smallest in ascending order. So from smallest to biggest. Not descending, that would be biggest to smallest, but we want ascending, so smallest to biggest. So the first thing we're going to look at is insertion sort. Now what does that do? Basically what it does is it just goes like this, 10, and then it will go through and look for the smallest one, and it will see 5, and it will store that 5 in a temp. It'll store that 5 in there. Actually, sorry, it'll store the 10. And then it'll put 5 in index. It'll put 5 in index 0 is equal to 5, and then it will store 1 is equal to 10. Now, why am I going over this? The one reason would be that this is really slow. I mean, it's very easy to understand. You just go through and check in an if loop to see if it's smaller, and if it is, it goes in there. But you notice there's a lot of moving. You have to move stuff 3 times technically. You have to move 10 and save it in temp so you don't get rid of it. Rewrite 5 here. Set 5 to temp again. So there's 1, 2, 3. So if you were counting how many operations, this is 1, this is 2, and that's 3. So you already have 3 operations just to do once. And then you would go through, and then at the very end you have what you're looking for. Now that would cause a problem, right? Because it is relatively slow, and you want to go for speed. So algorithms, of course, are, number 1 is you want to get it to work first. So this one works, right? It'll do what you want to do. But depending on the hardware for the PC, it might be slower than a lot of other algorithms. Now, like I said, the reason why I'm telling you this is that the art of computer science is messing around with things to make it faster. That's what's gonna make a difference between you and your competitors. Is your programs are faster, cleaner, smaller size, less code, takes shorter time. That better competitive is what I'm talking about. So next they thought, oh hey, instead of selection sort, let's do insertion sort. And basically what insertion sort is they got this first array and just did a second array. So you don't have to save anything. So for example, we have this array and then we have a second array. And for example, imagine that that's 0 through 5. So what they do is they just compare the first one to the second one, and if they find the lowest value. So they say 5, okay, and then they insert into the new array at 0, they insert 5. So now they only have to move it once. This is only one move. Of course, you have to check the same amount of times as the previous one, but you're only moving it once. So you cut down 2. So this is a lot better. In this case, smaller is a lot better than the bigger 3. This is better than 3. So now you have less operations and your code is quicker. All they had to do is add just another array. Their problem solving method was add another array and insert in the values that way and get 1 move instead of 3. So that's a way of thinking it there. And then they came up with an even better idea called merge sort, where it's similar to calculus ideals that as a limit approaches 0, it gets easier and easier to where you don't even need to sort it. So what does it do? It just goes in and cuts the array in half, and so you'll have the original array, you'll have another array, you'll have another array, and then you'll have a final array. So then all it's going to do is just sort these pieces here. So it just sorts these from ascending order. So in this case it would be 5, 6, 10, and then here it is 7, 8, 9. It's already sorted. And then it would just merge these two together, smack, smack, moves things only once. And now you have the option that these could be even sorted already. And then it'll merge and compare these to each other and see which one goes first. And then compare this one. So it says, okay, the 6 is here. So let's put the rest of these in there. So it goes 5, 6, 7, 8, 9, 10. Now this guy, of course, increases the complexity, because you have to cut this guy, and you can even cut it again and again and again and again to where you get maybe only 2, and then it's easier to replace those to where you could have maybe 15 arrays, and you could do recursion, just keep cutting up arrays and incrementing the identifier value. So it's like index 1, index 2, index 3, or you could say array 1, array 2, array 3, or array 4, or array 5, and have a counter just smacking that into a string and plopping that in there. So you could get it down to infinity to where it's almost, you don't even need to compare them, that they just get cut down and you just compare them in. So now the funniest thing is that it's kind of weird that like, oh hey, this is faster than the other one. Yes, it is. It is faster, and it requires a lot less time. That's why this is the number 1 sorting right now. They might have come up with a different one, but out of those, selection, insertion, merge is the fastest. There's also bubble, but we skipped over that one. Now here you have a call to where you cut up the array, which is no problem, initializing array, initializing another array, and you only have to read through the array smaller times, but you do it twice. I mean, you could separate this out on different threads. is that this guy could be, you could have thread 1, which we'll go over threads later, thread 2, and these won't conflict. So you could have 2 different threads. Now, you can't have one thread working on the same thing at the same time, moving them around. It will cause problems. But here, now you could have the separation of threads, and you could even have 3, 4, you have 4 threads, or if you're multi-threaded and you have multi-thread support, you could have up to 8 threads, or depending on the processor, if it's 4-core, you could have 8 threads on Intel. But here you have 1 and 2 threads for, a dual core without multi-threading, and you could separate them out and do separate things at the same time. So next thing you know, you have, instead of everything focused on this, you have different threads doing different things. So that is what a lot of people need to think about with programming. Just like everything, take it small. Break things down into pieces. And even math uses that a lot, cutting up pieces in calculus to figure out, the distance between the curves and the area between curves and things like that. So you're breaking it up into smaller pieces to have less work. And a computer could keep track of all these different pieces. Now this, of course, is what you're drawn to in computer programming. Because you could come up with an app and you could be like, okay, I'm done. But that's not, especially in a work environment, that's not what you're looking for. The boss is looking for something that you build and then you keep improving on it. So I'm telling you that here, stuff isn't always going to be perfect the first time you do it, but the question is what you need to work on is the logic behind working on something and getting it faster and faster and cleaning it up, cleaning it up, cleaning it up. And then as you learn more things and go on to more projects, you bring that back. So it's a continuous circle. You learn more things, and someone else learns something, advances technology, then you use that again. I'm sorry if this is kind of rambling on. I'm kind of seeing that this tutorial is kind of useless, but I mean it's something that I can't tell you enough that is important, that you write something and it might be junk the first time you write it, but then you just keep going at it and you get faster and faster. So as you see here, insertion sort was simple, it was easy, it required 3 lines to move it besides the comparison, because the comparison is the same within all of these. So I'm just saying what's different between the two, and the moves are different, but the comparisons are the same. So you could have something that's very simple, and then eventually you find, insertion sort, where you could create another array and just flow them into the array rather than storing them. So you're only moving once instead of 3 times. And you could do that a lot quicker. And then you might find this one where you could break things into smaller parts and do things even quicker, depending on how you set it up. So that's the takeaway of this, and is that now that if you're independent, just learning by yourself, and you're not wanting to get, you don't really want to learn data structures, and this is your last video of this particular series until you see some other specialized series coming from me, is that build something and just get it to work first. Get it to work, and then file it down to where you get to the point that you could make it very easy to understand for yourself. And then when you get it to understand and get rid of all the garbage, just make it quicker, quicker, quicker. And then eventually, as you move on in programming, you will come up with those ideas before you even start working on it. You will see those opportunities before they come back to bite you because you lose performance. And that's just my personal opinion, and how I'm adding on to trying to help you become a better programmer, is that practice, practice, practice. Go from project to project, work on things, program more code, look at other people's code, and just keep looking at code and working on it. Of course, don't just look at other people's code. You got to do your own code too. But set apart some time in the day to look at somebody else's code and really perfect what your app or your program or whatever is, and perfect that, make it faster, cleaner, and get into that mindset of a programmer to see things before they happen. Get down with I should probably even have programming drafting tips, where you get a piece of paper and you write down what kind of methods you want in there, what you want each method to do, have comments in your program, and all those other different types of things. So yeah, I'll figure out where I'm going to put this tutorial, if I'm going to put it in a couple places or just one. And I hope you guys got something from this. I tried my hardest to get this point across, that there's always a better way of doing things. You keep doing it the same thing, you keep doing it the same way, you're gonna get the same results. So get back into it and publish your app or whatever you want to do. Publish your program, and then break it at home until it gets faster and faster. It's not going to affect the app that's up on a website, embedded on a website, or on a phone, until you update it. So just work on it and get it faster, and each time you work on it, it will help you with that program, as well as developing that mindset, and it'll help you in future programs as well. All right, so this has been Steven from LegitTechTutorials, and I'd like to thank you for watching my little tips tutorial, and I'll see you around for the next video. And we're going to delve higher for Java. We're going to delve higher into these sorting algorithms, and I will see you next video. So if you like my videos, please subscribe for more videos like it in the series, and other series like it, and email me if you have any questions, and I'll see you in the next video. Thanks for watching.